if we think about what happens with the bronchioles, love that one. Have y'all ever seen the videos of eggs moving and how you've got like this little wave action going? Okay, these are cells that are helping to do that. The secretions into the stomach and the intestines, and then for absorption. So, those cells are pretty cool. Now, stratified squamous. Stratified, how many layers? 2 or more. Okay, so we got more than one layer. Squamous, my fried eggs. So I've got 2 or more layers of the fried eggs. So this is what they'll look like. 2 or more layers. Holy cow. How many layers does it look like here? Quite a few, right? Okay. Still, I have some connection down here to a basement membrane and sitting on my connective tissue. But wait a minute. These cells are avascular. How much of a blood supply do you think these, well, I shouldn't say blood supply, source of materials, how much do you think these up here have as the source of materials versus these down here? Way less. To the point that the further the layer moves from the basement membrane, the cells will begin to die. For example, skin. This outermost layer, cells are dead, they're keratinized, and they're sloughing off. And we're leaving them everywhere. How many did they say per year? Like 1.6 pounds or something? Oh no, was it 6.1 if you took off? Anyway, bunches of cells we're leaving everywhere we go. All right? That's kind of cool if you think about it. But anyway, there are multiple layers of cells. Sometimes it'll be cuboidal at the bottom, but squamous at the top, such as what we're going to find with the skin. Their job in, what we're going to see, we're going to have some that are considered moist, some that are going to consider hardened. For example, in our skin, this outer layer is keratinized, which makes us waterproof, which was really good for the past few days, okay? Because I don't know about y'all, but I really thought, you know, it was going to get washed away some days because of all the rain. Their functions, they help protect against abrasion. They help protect against chemicals, infection, invaders that might be trying to get into us, water loss, making us waterproof. Not just us, but other organisms, okay? For example, have you ever watched ducks on the water or ducks on land? And one thing they do, they get that head and they turn it around, they got, you know, their beak and they kind of diddle down and pull their head up like that. They have wax glands at the base of that feather, and as they go down and chew on it, it releases wax, and when they pull back up on it, it makes it waxy, and therefore the bird's waterproof. For us, we're lucky, all right? It's doing it inside the cell for us, making us waterproof, which is kind of cool. If you think about it, it's kind of cool. Stratified cuboidal. Something that is relatively rare in the body. Stratified, 2 or more layers. Cubes, they're shape. Sweat gland ducts, ovarian follicles, and the salivary glands. This is the only place you're going to find this particular cell. 2 or more layers, their job, either secrete or absorb. and they give us a little bit of protection against infections. And they will look like, under the scope, 2 or more layers of the cubes. Sometimes you have to make sure to have the scope focused pretty well, all right, for it to be visible. But all the pictures of what you're going to look at under the scopes is going to match what you're seeing here and in your lab manual, which is pretty much the same. Now, stratified columnar. Once again, very rare in the body. 2 or more layers of the columns. It will look like they're sitting on cubes found in the mammary gland duct. When is that active? When breast milk is being produced. So we're talking, that's very rare. The larynx and a portion of the male urethra. Like I said, it'll look like they're sitting on cubes with the columns. Their job, they're good for protection. Think about the male urethra. And then secretion, the mammary gland. So those cells, they're kind of cool, but don't get to see them too much. Now the pseudo-stratified columnar. These are kind of cool. Looks like more than one layer, but it's actually one cell that goes all the way, maybe not go all the way, but for the most part, they reach the apical surface, the free surface. Nasal cavity, our sinuses, the ears, pharynx, trachea, bronchi. A lot of the things that go with the respiratory system. Help to synthesize, meaning make, and secrete mucus if they have goblet cells. And this is the reason that they're named goblet, because it looks like you've got the handle of the glass and then the glass, and it looks like it's upside down sometimes when you're looking at it on the scope. They help to move the mucus that is being invaded by little foreign particles from these openings to the outside of the body, so that it actually creates that expulsion of those foreign particles. The transitional epithelium, the one that's in the bladder, the ureters, the urethra, this is the only place you find it. They change shape. They go from what looks like the fried eggs when they're flat, meaning the bladder would be empty, to where the bladder has expanded, and they begin to pull, and they look like they're the cubes or the columns. They help to accommodate for this fluid filling, and they also produce materials that keep the bladder, and well, for a lot of part, the bladder, but keep it from caustic effects of urine. Because urine, the pH, usually about 6 for the pH of urine, which is somewhat acidic. And because these cells produce a coating that can exist in the bladder, it doesn't cause the acidic urine to eat through the cells and cause a hole in the bladder. So under the epithelial cells, okay, because that's what we've talked about so far. The epithelial cells, their job: diffuse, filtrate, secrete, absorb, protect, move something, stretch, and then some other little things. Their shape, is going to, their shape and their layers is going to determine their function. So how many layers are present and the shape of it will determine, is it going to be diffusion? Is it going to be filtration? Is it going to be secretion and absorption? As you go through the remainder of the systems that you're going to cover, okay? Because we're going to cover, let's see, we'll do integumentary, bone, muscle, nerve. So the majority of your systems are going to be in part 2. And for what we cover, this is going to come back. These cells that are going to be present are going to have an effect on how that organ functions. And what did I say was the ultimate, what did I say the level is that we'd always get down to? Cellular level. Ta-da! Which we've got more to go through. Take a break. Be back at 3:30.